We're going to go over your Test 2 review on chapters 4 and 6. The first question talks about, is wine good for your heart? Is there a relationship between wine consumption and heart disease death rate? The table below gives data on average per capita wine consumption and heart disease death rate in 19 countries. So we have the country, we have the wine consumption, and we have in liters per year, and we have the heart disease death rate per 100,000. So the first question, and the most important question, is to figure out which is our explanatory, our X, and which is our response, the Y. So the wine consumption is going to be our X. That explains the heart disease death rate, Y. I'm going to put the wine consumption in list 1, and I'm going to put the heart disease death rate in list 2. But before we go to our calculator, step 1, figure out which is X, wine consumption, figure out which is Y, heart disease death rate. Then we're going to sketch what we have first, then we'll go to the calculator. So when we do our sketch, wine consumption is going to be on the x-axis. The heart disease death rate will be on the y-axis. Then we're going to look at the data. So if we look at the wine consumption, the lowest is 0.7, so maybe start at 0. The highest is 9.1, so maybe go to 10. And if I'm going to go to 0 to 10, I'm going to count by ones. So we have, well, maybe twos. So 0, 2, 4, 6, 8, 10. So we first have to decide where to start, where to end, and what to count by. Then the heart disease death rate, the lowest is 71, and the highest is 300. So we can go from 50 to 350 or 0 to 350, all those work. I'm going to go from 0 to 350, 0 to 350, and I'm going to count by 50s. So we have 0, 50, 100, 150, 200, 250, 300, up to 350. Notice I do all of that first, then I'm going to go to my calculator. Okay? In my calculator, I'm going to go ahead and press Stat, number 1 for edit, and then in list 1, we're going to put in our wine consumption. So notice I have 2.5, 3.9, 2.9, 2.4, 2.9, 0.8, 0.91, 0.8, 0.7, 7.9, 1.8, 1.9, 0.8, 0.65, 1.6, 5.8, 1.3, 1.2, 2.7. Then on the list 2, the Y, I'm going to put the heart disease death rate. 211, 167, 131, 191, 220, 297, 71, 211, 300, 107, 167, 266, 227, 86, 207, 115, 285, 199, 172. We want to make sure that both lists are equal, right? Make sure my calculator is all within the screen so you can see it all. Okay. Then we're going to put the data in the calculator, step 1. Step 2, we're going to tell the calculator that we want a scatter plot. So I'm going to press second, y equals. Notice that plot 1 is on, that's okay, but plot 2 and 3 should be off. Go press 1 or enter for plot 1. Press enter on. Choose the first option, which is scatter plot. Then for x, it's list 1, that's where my x is, second 1. For my y, we're going to put list 2, second 2. I'm going to choose the box for my dots. And then I'm not going to use zoom 9, I'm going to make my own window. So if I'm going to press window, and if you remember from our picture, our x minimum was 0 for wine consumption, x max was 10, and my scale was 2. My y minimum was 0, my y max was 350, and my scale was 50. Once I have everything in, I press graph, and we're going to do a sketch of what we have for our scatter plot. We're going to do a sketch for our scatter plot. So draw the best you can. Doesn't have to be perfect, but you're going to draw the best you can. And let me try to put that in there. Again, doesn't have to be perfect, just kind of represent the best you can. Again, you could do this all by hand and make sure everyone is perfect, but I think we got the idea. We got the idea that we have this picture showing wine consumption and the heart disease death rate. So that is our scatter plot. Now, the next question talks about what is the form, correlation, and other questions. So the first one is, what is the form? So the form will be linear. Dots are forming a line. What is the correlation? Now, to do the correlation, which is also to do the linear regression, you press stat, 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 to the right for calculate, to the right for calculate. You can use number 4 or number 8. I'm going to use number 4. So press 4 or go to 4 and press enter. And depending on your calculator, this calculator is list 1 and list 2. So with X we put list 1, second 1. Y we put list 2, second 2. Go down to calculate and press enter. This will give you your linear regression. This will give you your linear regression. Now, if you have the other form of the calculator, you may have to put linear regression, and then it's asking for list 1, comma, which is above the 7, and then list 2. So list 1 is second 1, comma, above the 7, list 2, second 2. Okay, so our correlation, according to our calculator, is the R. Remember, R is correlation, and that gives us negative 0.84, negative 0.84. Then, explain what the correlation means as far as strength and association in the context of the problem. Well, a couple things. Number 1, notice the correlation is negative. Notice the correlation is negative. Also, notice the correlation, we're going to say it's strong because it's close to negative 1. And if we look at the negative strong relationship, what are we saying? We're saying as wine consumption increases, the heart disease death rate decreases. Now, remember, we're saying that's what appears to happen. That's what appears to happen. So the next question says, based on the value of the correlation, does that mean wine consumption causes heart disease death rate? Now remember, no correlation doesn't imply causation. Okay, just because they look like or they're correlated doesn't mean one caused the other one. Then, going back to our calculator, we have that R squared. R squared will say it's 0.71. What is that telling us? Well, R squared is 0.71, which is 71%. That tells us that 71% of the data is explained by the line. Now, what do I mean by line? Well, when we look at this picture from the calculator, they gave us a line. Y equals AX plus B. You have to put in A for A and B for B. You have to put in the A for A and the B for B. So, when we do that, you're going to get the line Y equals, I'm going to go 2 decimal places, negative 22.97x plus 260.56. Now, when I go to my calculator, I'm going to sketch that. So I go to my calculator, press Y equals, make sure you use the negative button, negative 22.97. X is located to the left of stat, plus 260.56. Hit enter, hit graph, and that line goes right through the data. That's how you know you did it correctly. So I'll sketch that in my graph. Okay. Then, next question, explain the slope. So remember, when you explain slope, first of all, the slope is the number in front of x. Negative 22.97 over 1. Slope is always output over input. So remember, output is the heart disease death rate. and the input is the wine consumption. So if I was going to explain this in a sentence, every 1 liter of wine consumed, the heart disease death rate decreases, because it's negative, and I'm not putting decreases negative, 22.97. That's per 100,000. Okay? The y-intercept is a number on its own, the 260.56. And remember, the y-intercept is when x is 0. X is wine consumption. So, at 0 liters of wine, at 0 liters of wine, the heart disease death rate is 260.56, technically per 100,000. Okay, put it up there if you want as well, per 100,000. Okay, now we can use that line to predict. So the last questions here says we're going to predict for 1 liter, for 5 liters, for 9 liters, and 15 liters. So if I use that equation and I plug in the 1, if I use the equation and plug in the 1, y for x, y equals 22.97 times 1 plus 260.56, and I'll work on all these. Y equals negative 22.97 times 5 plus 260.56. Y equals negative 22.97 times 9 plus 260.56. And y equals negative 22.97 times 15 plus 260.56. Now you can go to your calculator, type it in, but I'm going to go ahead and do these in the table feature. So again, you could just type it in, but make sure you hit second window for table set. Make sure it's ask auto, so independent it's ask, put enter on top of ask, and the dependent should be auto. You have in y equals the equation, so if I go to the table feature, second graph, I can plug in the 1, enter, 5, enter, 9, and 15. Enter, 15, enter. Again, you could just type it in the calculator as well, and you get the same answers. That works out just as well, Okay, so for 1, we got 237.59. For 5, we got 145.71. For 9, we got 53.83. And for 15, we got negative 83.99. Now, be able to write each of these in a complete sentence. So, for example, at 1 liter of wine consumed, the heart disease death rate is 237.59. At 5 liters of wine, the heart disease death rate is 145.71. At 9 liters of wine, the heart disease death rate is 53.83. And at 15 liters of wine, the heart disease death rate is negative 83.99. Now, at negative 83.99, that is outside of our data. Notice there's no country that drinks 15. The highest is 9.1. That is beyond our data, and the word for that is called extrapolation. And when you have extrapolation going beyond the data, generally that prediction is inaccurate. Okay? Could be, could not be. Okay? And then for the last two, this one, now we're going to plug in for y. We're going to plug in for y, because now we're given the heart disease death rate. So this would be 200 equals negative 22.97 x plus 260.56, and 100 equals negative 22.97x plus 260.56. So for both of these, we're going to have to do some algebra. Okay, when you do the algebra, this is going to be x equals 2.64 liters. And for 100, this is going to be x equals 6.99 liters. So at the predicted wine consumption at 200, heart disease death rate is 2.64 liters, and at 100, heart disease death rate is 6.99 liters of wine consumed.